Are you interested in creating powerful AI apps but tired of the complexity of multi agent frameworks? There's a new way to do this, and we're going to talk about it on this edition of Tech's Edge. So, what is Microsoft's Semantic Kernel? Microsoft's Semantic Kernel is like a smart toolkit that helps you build applications using artificial intelligence. So, imagine you have a virtual assistant like Siri or Alexa, but you want to make your own customized version for specific tasks like planning a vacation or summarizing long documents. Semantic Kernel provides you tools that you can use to create an intelligent application super easy. So, how does it work? Well, there's the kernel. So that's kind of like the brain of the system. It's the central hub that manages everything that's needed to make the AI work. And it keeps track of all the services and plugins that you add. The services part, these are the skills that you add to your AI. For example, understanding text, generating responses, or even connecting to the internet to fetch information. The third part is plugins. These are additional tools or functions that the AI can use to perform specific tasks, like accessing a database or making calculations. And the final part are the prompt templates. So these are like the scripts that tell the AI what to do. So you can create templates for different tasks, like summarizing text or answering questions. So why is semantic kernel better than, for example, multi-agent frameworks like Crew AI? Well, the main one is simplicity. So the semantic kernel is designed to be kind of straightforward and easy to use. So you don't need to worry about managing multiple agents or their interactions. Everything is handled through a single centralized kernel. So that makes it easier to develop and maintain the AI app. The multi-agent frameworks usually involve multiple agents, and these agents are small programs that perform specific tasks, but they work together. And managing these agents and their communication can become complex and challenging, especially if there are a lot of agents involved. There's another good reason, and that's modularity and extensibility. The semantic kernel is modular, so you can add and remove services and plugins as you need to. You can start with simple application, and then you can gradually grow it and expand it and scale it up without having to redesign everything. In multi-agent frameworks, while they can be modular, integrating new agents and ensuring that they work well with all the other agents sometimes requires a lot more effort and coordination. And another reason is focusing on AI and natural language. So the semantic kernel is designed to work with the latest models, like those from OpenAI. So it understands and generates natural language, making it really good at applications that need to interact with the users through text or speech. Multi-agent frameworks are more general purpose and not always optimized for natural language tasks. So you might need to add additional tools and configurations to achieve the same level of performance as the semantic kernel offers. And then finally, Microsoft believes that the semantic kernel structure is built to be accessible even if you're new to AI and programming, so that the clear structure and the documentation that they provide should make it easier to get started and build powerful AI apps quickly. Multi-agent frameworks, on the other hand, can be a little bit more intimidating for beginners due to the complexity of managing multiple agents and their interactions. So the learning curve can be a lot steeper. We're going to take a look at some code right now to see how it all works. Okay, so let's take a look at the code. This is the sample application provided in the GitHub. So let's start at the top and let's walk our way through the code. The first section is basically the imports. So first we're going to import the necessary modules, and we're using async.io for asynchronous operations, the kernel class from the semantic kernel, and the connectors from the OpenAI and Azure AI services. We're also going to bring in the prompt template config for defining the prompt templates and the load.env to load the environment variables from the .env file, which will contain our keys. Here we're loading the environment variables from a file name called secrets.env. So this is where we'll keep our OpenAI keys and our Azure keys. Next, we're going to initialize the kernel, and then we're going to set up the OpenAI services using the credentials from our environment variables. This allows the kernel to interact with OpenAI's chat completion services. Next, we're going to define request settings. So here we define the settings for our specific requests. We're specifying the maximum number of tokens, the temperature for randomness, the top P for controlling diversity, in the responses. And these settings tailor the AI's response to our needs. Next, we've defined a prompt template to summarize Isaac Asimov's 3 laws of robotics in exactly 5 words. This template is used by the AI to generate concise summaries. So next, we're configuring the prompt template. We create prompt template config object with our prompt, and we add it as a function to the kernel. This makes the function reusable and easily accessible. Next, we've also created a general summarization function that can take any input and produce a one-line summary with the fewest words. Next, we're going to run the prompts. So in our main function, we first run the initial TLDR function to summarize Asimov's laws, and the results are printed out to the console. And then finally, you can see here that we're summarizing different concepts. We're going to use the summarize function to generate concise summaries of different scientific laws, including the laws of thermodynamics, motion, and universal gravitation. Each summary is printed out to the command line. And then finally, the last part of the code is the main, and this is where we run our main function asynchronously. This kicks off the entire process and allows us to see the AI actually work. So that's it. That's the simple overview of this example application. That does it for this video. If you liked it, please consider giving it a thumbs up and subscribing, and I'll see you in the next one.